All right, we're starting with number 34. So it says a certain bacteria population is dying off. 3/4 of the bacteria die every day. Assume that there are 1 million bacteria cells initially. Write an equation to represent the number of bacteria cells remaining. After how many days will the bacteria cell population fall below 500? And then how many cells will be left after 5 days? Okay, so first of all, we have to decide whether this is exponential growth or decay. Because something's dying off, I would say the decay. So let's make sure we know what that should be looking like. It is going to be y equals a times 1 minus r, where r is the rate, raised to the x power, and x is going to be the amount of time, right? So my rate, they told me, is 3/4. That is 0.75. Okay? And then we're going to plug everything else in. A would be the initial amount. That's going to be the 1 million right here. So let me get another color. So the equation itself is going to be y equals 1 million times 1 minus the 0.75 raised to the x power. Now, the 1 minus 0.75, we probably should go ahead and do the subtraction on that. So 1 minus 0.75 is going to leave us 0.25 raised to the x power. Now it says, after how many days will the bacteria cell population fall below 500? So if x is the amount of time, the 500, we're going to plug into, I'll write it down here, we're going to plug into the y. Because that's what we're trying to see as our answer. So there's the 1 million, the 0.25, and raised to the x power. Okay, because we're solving for x, guys, we can just put this into nsolve, okay? So let me flip over to the calculator. Okay, so I'm just in a new document, and I'm going to go to menu 3.1 to do my nsolve, and I will type in 500 equals 1 million. Make sure you get all the number of zeros you should have in there. Parentheses, 0.25, close my parentheses, raise it to the x power, and then be sure and move your cursor over 1 before you do your comma x. And so it's asking how many days. So it looks like 5.48 days, so about 5.5 days. So if we flip it back over to our worksheet, we will write 5.5 days. Okay, the next one says how many cells will be left after 5 days. So now we're going to type in our equation. We want to know after 5 days. So the x is representing the number of days or the time. So we'll type in 5 for our x. So let me go back to the calculator. Okay, so we're going to type in, we have the 1 million, parentheses, 0.25, and then instead of an x, remember we're raising it to the 5th power because they want to know how many cells will be left after 5 days. So this is how much will be left right at 5 days. So 9.76, 0.56, 976, about 977 if you approximate, cells will be left after 5 days. Okay, so C, I went ahead and wrote it right here for you, 976.6 cells. I just rounded to the nearest tenth. All right, so if we look down here at number 35, it says a certain stock is losing value at a rate of 35% a week. Assume the stock was originally $500. So it tells us that we're losing. So again, we're going to be using the same decay formula right up here. 35%, we need to write this as a decimal, so 35% is 0.35. So if we use the, write the equation, we will say y equals, and the amount that we started with was the 500. And then we will say 1 minus the 0.35. And again, we're raising that to the x power. Again, if we went ahead and subtracted this, we would have y equals 500 times 0.65 raised to the x power. All right, so B says, after how many weeks will the stock be worth $10? So again, we're going to put this in our calculator, and we're going to type in $10 equals the 500 times 0.65 raised to the x power, and we'll put that into InSolve, okay? So let's go there. Okay, so from here we can just go to InSolve. So menu 3.1. Let's type that in. We had 5, was it 5? No. Oh, $10. So 10 equals the 500. Oh, I didn't do InSolve. Hello. What happened to that? Menu 3.1. Let's try that again. Menu 3.1. Okay. Now, $10 equals the 500 times 0.65 raised to the x power, and then my comma x. And so that tells me after about 9 weeks, the stock will be worth $10. So if I go back to my paper, so right here, this is going to be, oh sorry, there we go. So after about 9 days. Then it says how much is the stock worth, now worth 4 weeks later. Oh, 9, sorry. This was 9 weeks, not days. Sorry, okay. How much is the stock now worth 4 weeks later? Okay, so that's where we're going to plug in. We'll have the y equals the 500, 0.65 raised to the 4th power. And then all we have to do is solve that. So again, let's go back to the calculator. Okay, we're not solving for any variable this time because we've replaced our variable with a number. So we have the 500 times 0.65, and then we're raising it to 4, because that'll be for 4 weeks. And we hit enter. So remember, we're talking money, so we are going to have $89.25. So $89.25 would be your answer for that problem. Okay, so we're on number 36 now. It says the Zelda triangle is a triangle with 3 white triangles drawn inside as seen to the right. Each of these triangles has 3 white triangles drawn inside of them, and so forth. Write an equation to represent the number of white triangles that will appear. All right, so we are using our exponential function equation, and that was just y equals a times b raised to the x power. Okay, so let's look at it. So we are starting with 3 figures, right, or 3 triangles, and then so I'm going to put 3 here, and that is going to be raised to the x power. And then we have 3 more triangles in each one of those. So if I say 3 times 3, in other words, hang on. Okay. Because I am taking each one of these triangles and I am tripling it basically. There's 1 triangle here, but now there's 3 triangles. I'm going to be multiplying by this 3 on the outside. So here's my equation. So on B it says how many white triangles will appear in the 8th iteration. So the 8th is going to go in my x. So I'm going to have y equals 3 times 3 raised to the 8th power. So we can put that in our calculator. And when I do, I end up with 19,683 triangles. And again, when you put this into your calculator, you guys, you're not doing an InSolve. You have all these numbers right here. You just type it in the calculation area, and you'll get the answer, okay? All right, so let's try number 37. It's very, very similar. It says a tree has 4 branches like the one shown. Each week, each branch grows 4 branches of their own, and so forth. Write an equation to represent how many small branches there will be. So again, we are starting with 4 branches, and that's going to be raised to my x power. And then it says each branch will grow 4 branches. So we're going to be multiplying by that 4. So again, then on B it says after 5 weeks, how many of the small branches will there be? So y equals 4 times 4 raised to the 5th power. And again, I can type all that into my calculator, and all of this, right? Not doing InSolve. And then I will get a total of 4,096 branches. Okay, so on 38, 39, and 40, we're talking about range and domain. So I probably will do most of this just on my calculator and not flip back and forth, but let's look at some key words. It says find the range values of this function. The range values would be the y, you guys. So that means all of these values are my x, okay? So what I'm going to do is just go to my calculator, and I'm going to type this equation into graph, and then I want to get the table. So that on the table, I'm just looking for these values, a -4, and a -1, and a +2, and a +6. And then I'll have my y values, okay? Then on the next one, I'm going to do the same thing, but look what's happening now. It says find the domain values of the functions. The domain is the x values, and that means these are my y values, but I can do the same thing, can't I? Can I put this into my calculator under graph, look at my data table, and I'm looking for these over on this side. Okay, and let's see what we can do. And then we might come back and do number 40. So let's go to the graph, to the calculator. Okay, so I'm going to go to a new document, and I don't want to save anything, and I'm going to go to graph. Okay, so my first equation was a -2x plus 4. Hit enter. I don't really care about the graph itself. I want to get to the table. So Control T to get to the table. Now remember, I was looking for my domain values of this. Here's my x and my y. My domain values were -4, a -1, a +2, and a +6. So if I go over here and I arrow up, I can get to my -4, which is going to be a +12. My -1 is going to be a +6. And then I arrow down. I'm looking for my 2 and my 6. I can't get them both. Here we go. Okay, my 2 is going to be 0, and my 6 is way down here at -8. So I would write my answer like this, though, because that's how they gave me the domain values, were in the braces. So I need to do the same thing for my range. So this would be my range values for number 38. Okay, let's see if we can go on and do number 39. Okay, so I'm going to, again, add a new page. I want to add a graph. My graph this time is 3x plus 6. Enter. Again, I just want to get to the table. Control T. Now remember, this time they've given me the range values, and I'm looking for the domain values. So let me write that down. I have the range values are -9, a +6, a +12, and a +81. So let's see what we can do. Oh, look, right away I see 12, and that's at 2. And that's all I see. Okay, so let's keep going. If I go this way, here's 6. So that means my domain value was 0. Let's keep going. Here's -9, so I have a -5. And then I need to go the other direction to get my my 81. Going. There we go. Here's 81. So my x value, or my domain value, would be 25. So again, let's write it with the braces. So I have a -5, 0, 2, and 25. This is a 5. Okay?